I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Nimrod Nehushtan, Executive Vice President, Mobileye. On today's episode, we'll talk about Mobileye's approach to autonomous driving and how vertical integration is helping them scale globally. We hope you enjoyed this episode. Nimrod, welcome to the podcast.
Thank you, Grayson. It's a pleasure to be here.
It's great to have you here. Historically, Mobileye has been a leader in ADAS technology, and as that technology has evolved, Mobileye has moved into full autonomy. How is Mobileye approaching full autonomy?
Yeah, that's a great question to start off with. So our strategy is a diverse product portfolio that scales from driver assist systems to self-driving cars. And the way we kind of represent the products in our product family is from the perspective of the driver. What will you as a driver or as a user be allowed or not allowed to do? And it starts with hands-on, eyes-on, which means as a driver, you're driving, and there are a increasingly more sophisticated driver assist systems that practically helps you prevent dangerous events, help you avoid accidents, and over time offers some comfort features like cruise control. But that is still within the realm of, as a driver, you're driving. And there is as I said, a increasingly more sophisticated technology stack that will improve your experience as a driver. The next product is called Supervision, which is a hands-off, eyes-on product. So as a driver, you enter the car, you select a destination, and the system can drive from point A to point B in all road types, in all environmental conditions, in all markets. But as a driver, you still need to be concentrated and focused and be, let's say, willing and able to intervene and prevent dangerous events if and when the system will be challenged. From that, we move to Chauffeur. Chauffeur is a eyes-off, hands-off product. So as a driver, within certain design domains, you will be allowed to take your eyes off the road and do other things. This is a significant kind of a transformational step compared to driver assist systems because it opens a new value proposition to consumers, which is buying back your time. And I think that the time is one of the most important aspects of driving today that is most bothering a lot of users, and it seems to only be getting worse in developed countries. And finally, our last product is Mobileye Drive, which is designed for mobility as a service and for fleets that will be transporting goods and people, ride-hailing with no driver in kind of a certain area, let's say a city, for example. So this is kind of our product portfolio and the family of products that Mobileye has been developing. The last three products are relatively new to our offering. And as you said, historically, we've been leading and leaders of the first category of the driver assist system. And I can say that the strong reputation of Mobileye as a technology leader and as a company that is always innovating and delivering new technologies in automotive and meets all the strict standards for safety, reliability, and the strict cost challenges that the automotive industry imposes is a very, very strong starting position and advantage that we have. And also our relationship that we have built over years with car makers is leveraged to kind of launch and create partnerships with our next generation products, our autonomous vehicle product families.
How do you see all these different technologies or at different automation levels complementing each other? Are you learning from all of these historical developments to perfect your L4 product?
Yeah, so the way our product portfolio is designed is in a very scalable and modular way, so that each product can be used as kind of an enabler, facilitator, or an accelerator for the next product in its line. So the way the Synergies work is through the compute unit, the sensor set, and some software aspects. So the driver assist system normally it has less sensors and a more efficient compute unit because the price is relatively low. But still, you can use the performance that you have in this sensor set with this compute and then build on top of it and use this as kind of a safety layer for the more advanced products. And Supervision has 11 cameras, and this camera set is being used for Chauffeur. Chauffeur adds to these cameras redundant sensors for safety radars, for example, and then we can improve the performance and reliability of the supervision system and allow the driver to take the eyes off. And this is how we get to chauffeur. By adding more compute and a little bit more sensors, we can get to drive to support the unique use cases of a ride hailing in a city environment. So this is kind of a very stacked, like a stacked, scalable design of products, which is in order to maintain the highest level of performance with the maximum efficiency for each product in itself.
When you achieve the drive status for your technology, does that require pre-mapping, or what goes into that prior to having, say, a robotaxi deployed using your drive technology?
So we basically work on a few specific cities in our development right now. And within these cities, we have recurring testing activities of fleets that we are doing with our partners. And that includes kind of, let's say, pre-mapping of the area. Although the way we use our maps is a very sophisticated way within our AI stack. So it's kind of an input to the AI stack, and maybe not in the traditional way that high definition maps were normally considered to be used. And in principle, our products are built on a very, very strong AI stack. And we are leveraging all of the assets that we have, for example, the data from the vast ADAS fleets that we have built over the years to train the state-of-the-art AI models that are being used for the level 4 product, for example. And that is how we can use our competitive advantage of being world leaders in ADAS and having a lot of customers from different markets and a lot of cars on the road. Mobileye has close to 200 million cars on the road today with our products that were launched over the years. This is a very, very significant number, and every year we increase, tens of millions of cars more to this fleet. And all of these projects generate data that we use not just to improve ADAS, but also to build kind of the next generation technology stack for self-driving cars.
Yeah, today, Mobileye, you have over 285 petabytes of real-world driving data. And we've seen you can't turn on the TV or go to a website, open a newspaper without seeing the word AI. It's everywhere. It's the new verb. What does that unlock for Mobileye? Does that allow you to accelerate development of your systems, or what is it really truly unlocked for Mobileye?
Well, I think eventually the challenge of self-driving cars is obtaining the safety standards, but also generalization and the comfort of driving. So it's not just about designing a system that is very, very safe and reliable and has a very low probability of accidents. It also needs to be useful, and it needs to operate in a wide array of use cases to make it really an impactful product. And with a proper utilization of the state-of-the-art AI technologies, it can really accelerate the generalization, how human-like of a driving experience it can generate. In some cases or in some aspects, you want a human-like driving experience. You want the comfort of the drive to feel like a very, very experienced and kind of a good human driver. But in some aspects, you want this superhuman capability. You want the safety to be much better than humans. So it requires a sophisticated design of the AI system, which we call compound AI system, which means a combination of multiple AI architecture, all of which are state-of-the-art and all of which kind of take the best out of each approach. And ideally, you can get the best of all worlds by the proper combination and the proper utilization of sensors, AI architectures, and then get to the superhuman reliability and safety, but very, very good human-like behavior for comfort and generalization of unexpected cases.
So obviously AI is advancing, your technology is advancing, I would probably say by the minute, because it's advancing so quickly. You're in 200 million cars, and when you get to your chauffeur product and your drive product, will you push out over-the-air updates as the technology, let's call it, is automotive ready, and you ship it then?
Yes, it is within the design of the system is kind of a loop of data that we get from the fleet, and then learn from this data, use this data to improve the system where it requires improvement, or to validate it before you launch and you expand your design domain, launch new features, and then you can deploy new software with existing fleets. So
in order to do that, there's a common denominator across the entire industry: redundancy. Where does redundancy come into the picture? Because when you read your public filings, you have the radars, you have the lidars, you have various different sensors. What percentage would you say are those redundant sensors there for when you use the term superhuman abilities? What percentage of those would you say are redundant?
Yeah, so maybe I'll answer this without going into percentages, but in principle, redundancy has multiple facets. So first facet is hardware redundancy. So you don't want to have a single point of failure in the hardware. For example, if you have a burnt PCB or burnt hardware component, then an accident can occur, right? Second type of failures or redundancy will be for sensors. So different sensors have different failure modalities. Cameras is very visual. So if you have bad visibility conditions for the human eye, then it might be challenging for the cameras to operate. Whereas radars obviously has a different failure mode. So this is kind of a sensor type redundancy. And finally, you can also think about algorithmic redundancy. So the software approach has its own strengths and weaknesses. Even the best technologies today has some weaknesses. Maybe the probability of these weaknesses to occur is very low, but still, if you want to design a system that will overcome the weaknesses of the software technology underlying the self-driving system. So we have a design that we've recently published a paper on this that's called PGF, which stands for Primary, Guardian, and Fallback. And this is kind of how we are implementing redundancies in our self-driving system, both on the hardware side, sensors, algorithmic, so that the probability of a failure of the entire system is low enough to achieve the performance level we're aiming for, which is very, very high for a reliable self-driving system.
You have to have reliable, or it's not going to sell. We look at reliability. This says a lot about your company. You have 50 OEM partners today. How does it work when the OEM partner approaches and says, Nimrod, we want to put an L4 system on the road? How does that process work? Because the vehicle's different architecture, different design layouts. Does Mobileye work hand in hand with your partners to develop or design the ultimate system, since there's different sizes and shapes of vehicles and different forms of power and transmissions?
Yeah, and I think this is a very, very good question. And I think that there are two parts to what OEM look for when they, need to select which partner or which path they want to take for level 4. And the way we look at this is kind of like an iceberg analogy. And so the tip of the iceberg is the technology, like especially AI today. And this is what everyone sees and everyone talks about. And as you said, you can open the news and you see something about AI. So obviously, it's the top of mind for most car makers. So you have to have AI leadership well ingrained into your company. It needs to be obvious, and it needs to be well represented over time with kind of strong or concrete, let's say concrete, tangible advantages. But it's not just about AI, because if you think about productizing self-driving systems with the state-of-the-art technology, it also requires some different engineering aspects. As you said, coping with different vehicle architectures, coping with different vehicle, let's say, even physical dimensions, different flavors that car makers want. Maybe, an Audi or Audi will have different preferences compared to BMW, compared to Mercedes, compared to others. Each company wants to differentiate and to own the user experience. So one of our biggest strengths is probably the experience we have built in how not just to communicate with OEMs, but how to design our products so that they can be optimally tailored and customized to different needs and different architectures that OEMs have, so that we can concentrate efforts on a common, let's say, common product that has enough degrees of freedom for, let's say, like the customizing, the product to specific needs and requirements that OEMs might have. And this is a very important trait that, combined with our reputation of getting to SOPs, getting to product launches in automotive and meeting all of the standards over time, really gives the OEMs more confidence that Mobileye is the best possible partner for these next generation products.
And then where do robo-taxis enter the picture? Because I'm assuming you're approaching the development of robo-taxis differently than you would of working with an OEM for personally owned on the chauffeur system?
Yeah, so it is different, but there are some commonalities. So our leading robotaxi partnership is with Volkswagen commercial vehicles, where the model in general is that Volkswagen is producing the self-driving car integrated with Mobileye self-driving system. So within the production line of the cars, they integrate the Mobileye self-driving system. The hardware, the software is integrated in the production line, so that mobility operators can then purchase these vehicles equipped with our self-driving technology and operate the fleet. So we are, focused on the position of the self-driving technology provider and partnering with car makers to produce the vehicle, and then with mobility operators to kind of operate and launch the service and to engage with consumers. That is kind of focused on our strength as a technology leader in automotive and gives us kind of a very scalable go-to-market for robotaxis. And this is kind of our leading program today. We're also in discussions with a few other car makers for similar models in different markets.
There's been various photos over the years of your vehicle and the VW van testing in Austin. When do you expect those commercial operations to begin?
Yeah, so without going into specific details that we cannot disclose, we talk about, let's say, a small amount of years for a commercial service to start. So near future.
So that's in the near future, but this is public statement. You have a partnership with Lyft. How is that partnership going to work? Because Mr. Risher, the CEO of Lyft, put out a very impressive blog post about their strategy and the role that Mobileye is going to play in that strategy. You talk about that partnership, please?
Yeah, so as I said, Lyft is a ride-hailing company. Today, they have a successful application that consumers use to book rides in different markets. And the partnership is such that these self-driving vehicles that are equipped with a Mobileye self-driving system will be used by Lyft to offer to consumers as a self-driving service within their application. That is kind of in principle what is the premise of this partnership, which means that our self-driving system is integrated with Lyft's operation or service operation management and everything that goes into this. And this is, again, a very important part because it's not just about the technology. It's not just about redundancies and safety and reliability. It's also about a scalable way to approach a broad array of consumers in different cities, different markets as quickly as possible. So that is an important component and an important announcement. Indeed.
One of the things that stood out to me in the press release, the joint press release I'll add, was this term Lyft Ready. The exact term, Mobileye Drive Equipped Lyft Ready Vehicles. To our audience, how would you explain what that is and what does it mean?
Yeah, so it means that Mobileye's self-driving system is compatible with Lyft services. So as I said, it means that Lyft, when we'll get to this stage, will be able to offer self-driving services that will use cars that are equipped with Mobileye self-driving technology. So it does require technical collaboration between the companies to kind of connect the Lyft service with the Mobileye system, and that is exactly what we have been doing, and that is the kind of the purpose of this announcement.
Will that be the drive system for your technology?
Yes.
And then earlier you mentioned fleets. Do you see this being, because Mr. Risher talked about this, potentially being deployed in fleets where there's a small business owner that buys, say, 100 of these vehicles, 1,000 of these vehicles, and operates them in a fleet? Or do you see your traditional rental car companies, your Hertz, your Avis's, your Budgets, buying these and operating them in a fleet?
Yeah, so I think it's there is no constraint that determines this or the other. And from our standpoint, we are flexible, and our technology is designed to eventually drive everywhere, in different cities, different markets, supporting all road types and all conditions. So the business model will eventually, I believe, will be determined by what makes most sense and what has the most demand and what has the most tangible, revenue at the edge of it. And that is something that, Lyft has their own plans and they do what they do, and they will, they can discuss more about this. From our standpoint, we believe that the more our self-driving system is scalable, cost-effective, reliable in performance, and again, can be relatively easy integrated in a broad array of architectures and vehicle requirements, that will maximize our gain from the market.
And staying on the drive theme, will your technology work on internal combustion engine vehicles and electric vehicles, or is it compatible with both types of vehicles?
It is compatible with both types, and you can think of it as kind of it's a box that is connected to the sensors and to the vehicle control system. So it's basically not dependent on the powertrain. And in practice, we have our supervision products, for example, are with Volkswagen Group, another project that we have with Volkswagen Group with our next generation supervision system has both EV and combustion engine models that integrate this. And for us, it's the same product.
And the big difference between the internal combustion and the electric vehicles is power, the power consumption. And your system, you have to develop it, as you said, to be superhuman. How do you balance that need to be superhuman with power consumption?
So that goes into our silicon and our hardware and more specifically silicon design. And that is one of the reasons why we have our proprietary silicon and we work with our chips. Our chips are purposely built for automotive and for self-driving applications. And it means that we are really scrutinizing the efficiency of the chip, not just in power consumption, but also in cost. And we try to maximize the performance we can achieve with no compromises. You do not want to compromise on the performance or to be limited with the advancement or how advanced the state-of-the-art technology that Mobileye is able to deploy because of the chip. And recently, we have published more information about our EyeQ6 chip, which is our next-gen silicon that will be used for this Mobileye Drive, Mobileye Chauffeur, Mobileye Supervision. And that chip is very, very efficient, but in performance, it is on par or even better than some of the other known names in the industry when it comes to silicon. So this combination of having very, very strong performance that is purposely built for what we are developing on the software side allows us to have a very efficient, both in power consumption, but also cost, which is equally as important, product that is not limited, but is constraints.
Has Mobileye always designed and manufactured your own chips?
Yeah. So from day one, the products the company sold were based on the Mobileye EyeQ chip. And this is the sixth generation. So starting from EyeQ 1, 2, 3, 4, 5, 6. And each EyeQ chip was designed, we normally have a couple of years between chips, and each chip was designed, to support the state-of-the-art technology at the time. And in the same way, EyeQ6 is really, really optimized for all of the en vogue AI architectures with very, very efficient design.
Do you feel that the EyeQ chip line gives Mobileye a competitive advantage in the market?
Yeah, as I said, I think the combination of having high performance at very efficient cost and power consumption, and this modularity that really by having multiple EyeQs, we can expand compute or reduce compute and therefore improve performance or at least expand the performance envelope or reduce cost. This is really a competitive advantage. We're not just a monolithic solution that can be too expensive or too low performance for anyone. Right? So this diversity and flexibility and efficiency are really, really critical to be a kind of a winner in what we do.
You have the chips, you have the software, you have the sensor suite. Zooming out for a moment, putting it all together, what's Mobileye's overall strategy for robotaxis? Because you have all the ingredients to make a really great cake. In this case, a robotaxi.
As I said, our strategy is kind of developing, and the product that we're offering eventually is the self-driving system, which is the hardware, the software, and in some cases, the sensors that for car makers, they can purchase this and then produce a self-driving car for level 4 robotaxis. And the way we do this is by kind of leveraging the synergies and scalability of our product portfolio. So one of the key traits for a successful robotaxi technology is how quickly can it scale from from one city to multiple cities, from one market to multiple markets. How quickly can you expand from just daytime operation to also nighttime, from clear days to rainy nights, and so on. And because eventually it's a question of the utilization of the fleet. Can it really work 24/7, 365 days, and in any city, in every market? So in order to get there, we're leveraging our very, very kind of high volume ADAS business and other products in our product family to accumulate data and to improve our underlying technologies so that the transition time or expansion is really exponential. So we might, once we are launching our robotaxi products, the time it will take us to expand is really, I think, competitive, I would say, due to our diverse product portfolio. So this is a very, very important competitive advantage, and this is why, this interplay between ADAS, consumer level 4, and then robotaxi really plays to our advantage.
What type of infrastructure did Mobileye have to build to train this very complex driving system that you built?
So we are, I think, following some practices that are very common today in the industry. And there is a good combination between on-prem compute infrastructure and cloud-based compute infrastructure. We have a very significant database, hundreds of petabytes of real-world data that we have accumulated for years from multiple car makers in all regions. And we have a very efficient operation for training, validation offline, and then going from offline to the online system, to the inference system. These are all infrastructures that are essential to be ahead of the curve in today's world. We have all of the assets, and in many cases we have unique assets like the data, like the inference compute, our AI expertise and experience in automotive, in understanding what it takes to launch a state-of-the-art technology in automotive, which is not a trivial market. It's not like ChatGPT, for example, has a shorter path and journey you need to take from the state-of-the-art latest technology until it reaches the consumer. Because if it fails and if there is a bug or if there is a glitch, then okay, it's a lot of bad press, but you can overcome it. And in automotive, there are very, very strict standards and regulation that you have to surpass and to be compliant with to launch a product and really, sell it in millions. And having this experience, this is like what stands behind what we have been building in the past few years.
With automotive, it's a zero-fail industry. You can't have hallucinations that you see with some of the bots. Overall, what are your thoughts on AI, and how do you see it evolving from a autonomous driving perspective?
I think it's a very, very exciting market, and AI has been moving very fast, and it moves fast across multiple frontiers. And I think what's interesting is that there are some commonalities in the, let's say, core principal problems that AI engineers and AI experts try to solve in language and in autonomous driving and in humanoid robots and in different applications. And I think that we have been seeing unprecedented progress and rate of progress in AI in recent years, and it seems to be accelerating. And we've been, as a company, we've been very, very deeply engaged in all of these technologies from early days. Our founder and CEO, Professor Amnon Shashua, and our CTO, Professor Shashua Schwartz, are both scientists and professors. And they also have multiple companies in different frontiers of AI. So our exposure and scientific premise, let's say, is really what gives us the edge of being ahead of the curve and being the first to experiment with kind of these interesting papers that come in this field and might be relevant or interesting to what we do. And also thinking about what is still missing and not what exists today. So it's really exciting, and I think the rate of progress has been remarkable. And we've been fortunate to have the right assets, the right team of experts, and the right leadership to be daring and willing to challenge everything we do when there is something interesting that comes up and requires a deeper thinking about our, let's say, legacy in a way. So that's very, very exciting, but also, it imposes its uncertainty. But I think it's what makes it exciting.
It makes it the rate of progress in AI. It's just every single day. It just seems to be accelerating. And you're right. If you're going to be a leader in industry, you constantly have to keep experimenting and trying new technologies. Some you might be able to commercialize, some you might not. But you still have to experiment and learn about all those new technologies, so you're not caught flat-footed. Nimrod, in your opinion, what is the future of Mobileye?
That's a fascinating question. And I think the future of Mobileye is very, very bright to begin with. And don't want to go into prediction. I haven't been to the future yet, so I cannot really tell you what will be, our future in 5 years or 10 years. But I think the way we are progressing, or the direction we're progressing, and this direction is really pushing the envelope of AI and how AI can be used in a very challenging use case of self-driving cars. And the progress we've been making in the past few years in this, not just on the technology side, but also establishing partnerships with car makers and having a tangible, I believe that the first meaningful partnership between a car maker and a self-driving system provider was with Mobileye. And you can see that leaders today in the industry are either fully vertically integrated, like Tesla or Waymo, or you don't still see meaningful partnership for full self-driving systems. So being at that position gives us a lot of optimism about the future. And it might take us a little bit longer to add more partnerships, or a little bit shorter. I cannot really anticipate, but I think the way it's progressing, within a few years, Mobileye will be one of the leaders, if not the leader, in self-driving technologies and products that I believe will be a very important and significant market. And maybe it will not be only Mobileye, but I think it's such a big market and the impact on on humanity is so significant that there is plenty to be gained for the couple or 2 or 3 or 4 winners that will be there when push comes to shove.
Autonomy is going to create jobs. It's going to have positive impacts on society. It's going to lower healthcare costs. We can go on for days about all the positive impacts. And if you do go to the future, if you run into George Jetson, tell him I would like to meet him, because that'd be really cool. But you're right. You have to keep building, and this is a very big market. And we're only in the first inning of a 9-inning baseball game of where this is going. As we look to wrap up this insightful conversation, hopefully next time we have it from the future, what would you like our listeners to take away with them today?
Well, I think that I'll try to kind of give my perspective from the lens of a consumer and not an engineer that is knee deep in the frontiers of what we do, because I think that it's very important to continuously ask yourself, why should I care about what this guy's been talking about the past 30 minutes? And thinking about this as drivers, as consumers, as people who consume transportation in different ways. Eventually, there are 4 factors that play into how well and how efficient the transportation system is for us. It's safety, it's the comfort of driving, it's the time we waste, and how much it costs us. And if we look at the past 20 years, let's say, since technologies has really started to penetrate automotive, there has been a very impressive progress in safety. So there are very, very advanced safety systems today that prevent collisions and prevent hitting a pedestrian and so on, that became regulation, that became standards. So that is very important. There is also some improvement in comfort. You have features like cruise control that gives you some level of comfort in your daily commute. There has been no meaningful progress in time. If you can argue it's been negative, that we've been wasting more time in a car than we have been wasting 20 years ago. And you can say that maybe the price per mile driven is roughly the same through this time. And I think what's very interesting to look forward to is that in the next few years, and again, I haven't been to the future to say if it's going to be next month, next year, or in 3 years from now, but I think it's very near future relatively, that we'll see a step function change in all of these factors. And that is an unprecedented event in transportation. And there is a good combination of the technology progress, the amount of time invested in this, and also I think social acceptance is becoming more and more, ripe to start scaling these technologies. And once it will scale, it will really transform the way people consume mobility. And I think this is the most important takeaway message. And Mobileye is a key enabler and a key actor in this theater. And I believe that we'll have a meaningful role in kind of crossing this chasm of where we are today and this exciting future, which will be a step change, we believe.
There's no doubt about the role Mobileye will play, because autonomy will increase safety. Autonomy will lower the cost of mobility. Autonomy will give you your time back, and the comfort is less stress. Autonomy will give you less stress because you're not pulling your hair out in a traffic jam or when somebody wants to play Mario Kart on the freeway. That's not good. We like safety. Today is tomorrow. Tomorrow is today. The future is Mobileye. Nimrod, thank you so much for coming on SAE Tomorrow Today.
Thank you very much, Grayson, and pleasure being here, and have a good day.
Thank you for listening to SAE Tomorrow Today.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.